Go ahead.
This is a presentation on software architecture and design. The project topic is on KWIC project presentation. Next, this is a presentation from group number 7. We have Cav in the group. We have Ajala Abiola. We have Vicent Lee in this group. We all work as a team for the success of this project. Abiola played the role of software architecture, whereby she ensured weekly meeting was held. She worked on the sequence diagram, the class diagram, the use case component diagram, and also worked on the documentation of this project. Solomon played the role of software architecture. He also works on the coding part. He ensured all the code was working well. He also ensured the diagram related to the code worked on the component diagram. And on the documentation, he also worked as well as creating video chat for explanation. He led the group to start extra early. He already had the code done a few days after the assignment was designed, and which gave us more time to talk about the shared data and the documentation in 4+1 view. Lee Vicent played the role of software architecture. He ensured all work was well done. He also worked on noise eliminator. He tested out the runtime memory and did the comparison between our last and previous code. He also created our deployment diagram by setting up team meetings. Here's a +1 view model. The 4+1 view model is used to describe the architecture of software-intensive system based on the use of multiple and concurrent view. This view is used to describe the system from the viewpoint of different stakeholders. Here is the logical view, which is the class diagram. We have the process view, which is the sequence diagram. We have the physical view, which is the deployment diagram, which was done by Lee Vicent. We have deployment view, which is the component diagram, which was done by both Abiola and Solomon Cap. And here is the use case diagram. And the use case, this is all about how the store word was stored in the input, while the input character maintained the user to accept generated inputs. The circular shifter is also defined using the offset and force to perform the circular shifts. That is the advertised word, which is used to define the algorithm of force and offset. We have the output, which is used to eliminate and display, while the noise eliminates lines, which is defined by the user. Next. We also have the sequence diagram. From the diagram seen, we realize that the main is being generated to the input, which reads and saves the line storage as packed characters. The circular shifter also reads packed characters from line storage. That is, it records the stats and offsets for each word in car index and then perform a virtual circular shifter. This keeps tracks of the circular shifter and the alphabetizer. The alphabet reads the record first, and the circular shifter word converts to the alphabetized index, which is being filtered and eliminated. Then it is being sent to the output for display. Next, we have the component diagram, which was done by both Solomon and Abiola. From here, we notice that the KY system component comprises of the circular shifts, the noise eliminator, the line storage, the alphabetizer, and KWIC controller, which is the main component that controls the system. The line storage stores packed characters. The noise filter eliminates lines. The alphabetizer inputs data, which is being displayed by the output. Next, we have the UML class diagram. This is an illustration of the UML class diagram. I will pass this to Solomon Cap. He's going to talk about how this UML diagram is being connected with the code he worked on, whereby from there, Vincent Lee will talk about the deployment diagram. Over to Solomon Cap.
All right, so I will talk about the relationships with the code and our diagram. So we have our main class that will launch KWIC, and then the input class, and we'll all see all this right here. So we got the noise eliminator as well, and the alphabetizer, as well as all this code. And I will show the code right here that we have everything as shown, as well as the use case diagram. Vincent, if you can go to the use case diagram first real quick. Yeah, okay. So on the use case diagram, I have the code here, which when we use from the main, just as we explained it, and then we run our code. We'll have a enter key where we can add line print with, and then Q to quit. And so we enter it inside the main through, and then it will get it from the KWIC, and then it will run the alphabetizer, circular shifter, line storage. And the only thing we didn't include on the class diagram as well was the line, because it is connected through shared data. And if you can go to our sequence diagram, please, on the next one. All right, so, and we can see that line storage shares data with lines. So we just implement it together on our diagrams, and then we show that by sequence diagram and class diagram. So we have line, but we didn't really name it like that because it is part of line storage, and they are shared data, just as everything here is shared data and implemented with object oriented. So if we go to our class diagram, yeah, we can see that our main, just like that, our main generates, the main generates using a generator to get what is inside the KWIC, and the KWIC data has all these inputs that are through shared data connected into object oriented, and then it is printed. It follows this structure, and then from the input it is printed to the circular shifter, line storage, and then it gets the circular shifter from the alphabetizer, and then that alphabetizer it gets connected to the noise through shared data, which will give us our output. So I will first go to Vincent Lee to show us how it is we're going to deploy it, and I will show how our program works. Go ahead, Vincent. You can show us our how we deploy it.
Okay. So right here is the deployment view, and for the fact that we have the share-OO.jar, that's going to be the artifact, and it's going to manifest all the components of class files, including the main, the KWIC input, the line storage, alphabetizer, circular shifter, and also the noise and the output. And that is being deployed on a node that's called my PC. And that's pretty much is for that. Go back to you, Solomon.
Yeah, you want to explain about the noise also, how you created the noise?
Okay, yeah. Also, with the noise, for a word, for a line that can start with any word, I would the noise component is gonna share the data with Solomon, code from the line storage.
Yeah, and I will show that.
Send it back to Solomon to put everything together.
Okay, and I can show that with for us right here. So going back to a Vincent deployment diagram. No, you can on the deployment diagram. You're good. All right, so from the deployment diagram, we enter our shared-OO.jar, which has all these files, just as Vincent said, which it manifests all these class and component files, and then we can deploy it inside my PC, just like so. I have already get the .jar artifact and download it here. As shown, we have all these, and it is being deployed into the PC, and now I'm deploying it right. I already have it deployed right here. So I'm gonna run it, and like I said, we can add a line by pressing A, and then let's say we add a line, hey, and then we just enter it. Let's say we print it, it will circularly shift and alphabetically shift that, and then we just press Q, it will quit. And then also if we want to block out any noise, we just press print again after add. So I have done this for the sake of time purposes. I put that inside of noise output, and this is just the regular output before print. Pressing print again, and this is just the regular one, regular output. We can see that it alphabetically and circularly shifts it, and then we can see that through the noise filter that Vincent provided for us, connecting it with shared data through line storage, as he said. We can see that any line that starts with the given like R, M and N, anything like that, it is being eliminated, and then those lines are being eliminated. So the lines that we see right now are only the lines that start with anything else besides that. So this is the clear output, as we can see. Nothing starts with that, and all those words are eliminated. And that's basically our program. And we will finish it off with here. And thank you for that. And you can go to our thank you page now. You can go to our thank you page now. Wait, we forgot one more thing.
All right, thank you.
No, actually, we forgot one more thing.
Hold up. Okay.
Yeah, performance comparison. So this is about the pipe and filter and shared data comparison that Vincent ran for us, and he will explain it right now.
Right. So for our current implementation, it's faster by using the object-oriented and shared data than the pipe and filter. When using the shared data, the time took is only 15 seconds, and that's is like 5 seconds shorter than the pipe and filters, which is 20. And the reason of that is because when using the pipe and filter, the heat area is take more space because of using the pipes, and that's caused the pipe and filters is getting slower compared to the shared data. And our object-oriented and shared data use better adjustment that make the implementation easier, understandable, portable, scalable, and reusable with good performance too.
Yes.
And I think that's wrapping up our
wrapping
presentation.
Up. Yep. Thank you, and we are.
All right,
wrapping
thank
it
you.
up. Thank you.
All right.